Welcome, ladies and gentlemen, to our continuing study of electric circuits. Today we're going to look at series circuits. Okay, a series circuit is a circuit in which there are multiple components, right? Multiple resistors, lights, motors, etc., but only one path for current to flow. If you look on the screen, you see a series circuit with 3 resistors. Okay, and what we're interested in is finding the current, the voltage, and the resistance for each part of the circuit. Okay, in other words, we're still concerned with those 3 primary quantities, current, voltage, and resistance, that are related to each other by Ohm's law. But we want to see now what that looks like in a more complicated circuit. All right, let's take a look first of all at current. Now I'm assuming that at this point that ideally you would have done a lab, okay, before you watch this podcast. And in that lab, you had to take some measurements with a multimeter of a circuit similar to this that also had 3 resistors in it. And what you found is that the current was the same throughout the circuit. Okay, so we can say that here like I typed it out, but we can also write it symbolically, okay, in mathematical form. And the way we would write that is like this. We would say that the current coming out of the battery, okay, which is often referred to as I, or sometimes I total, okay, IT, that is equal to the current running through each of the resistors. Okay. In other words, we're going to refer to the current running through resistor 1 as I1, okay, and so on. This is common notation for electric circuits, like that. So this is the words way to say it, right, and this is the mathematical way to say it. The current is the same throughout. There's only one path, okay. In the coal mine analogy, remember, the coal cars, right, the charges don't get consumed. They don't get less and less. All right, another reading you took in the lab was voltage, okay? You measured the voltage at different points of the circuit. And what you found was that as you went around the circuit from the positive end to the negative end, that the voltage got smaller and smaller, okay? Again, in the coal mine analogy, this is the same as the coal getting less and less, right? You start out with a full coal car, so in this case here, okay, if we drew a coal car, it would have, each coulomb would have 12 joules in it, right? 2 6-volt batteries. Okay, it'd have 12 joules in it. But here, right, it would have less than 12 joules because it used some of that energy at the first resistor, the first power plant. So it might be, it might be 10 here. Later on, we're gonna work out exactly what that number is. But the point is that it's less and less. Okay, so we can designate how much voltage is used at each resistor by saying V1, V2, and V3, okay, like that. And then I can also write this symbolically. I can say that the total voltage, right, which is 12 volts in this case, is equal to the voltage used by each of the resistors, okay? I can write that symbolically, the relationship of voltage in a series circuit. Finally, okay, we want to look at what happens with the resistors, right? When we add more resistors to the circuit, as your intuition probably tells you, and as the lab results showed you, the resistance gets bigger. Okay, in other words, the total resistance is just going to simply be the sum of all the individual resistances. Okay, so in this case, right, we have numbers here. 2, 6, and 8. 2 ohms, 6 ohms, 8 ohms, right? So the total is 16 ohms. I'll put that in parentheses here. 16 ohms in this case, right? Equals 12 volts in this case. In this one, we haven't figured out yet, but that's what we want to concern ourselves with the rest of the podcast. So I'm going to go to the next screen now and do exactly that. All right, so here we're starting from scratch. Let me get this out of the way quick. Okay, so you should be able to determine voltage, current, and resistance in any and every part of the circuit. All right, and the way you do that is you Ohm's law the circuit to death. That's right. You V equals IR the circuit to death. You use V equals IR, plug some numbers in, get an answer, and then use V equals IR again, and you get another answer, and then use V equals IR again, over and over. Hence the term, we're going to Ohm's law this circuit to death. Typically, a good way to start is to try to get the overall values for the circuit, okay, the overall voltage, the overall current, and the overall resistance, and then go back and work out the answers for the individual parts. Some of these totals are going to be pretty easy. Like, for example, let's start with the total voltage. Okay, that's usually pretty easy. Just add up the batteries, right? So in this case, it's 12 volts. Okay, and we already found the total resistance, right? 2 plus 6 plus 8, that's 16 ohms. Okay, so what we're left wanting to find is the total current. Okay, and you can find that using Ohm's law, right? So we'll take Ohm's law here. In fact, just to save space, I'm going to plug it in right here. So it would be 12 equals 16 times I, okay? And if you do the math there, that comes out to 2/3. Okay, 2/3 amps, like that, right? 12 divided by 16 is that 2/3? Oops, do the math. Can't even do the math. That would be not 2/3, but rather 3/4, which is actually kind of nice because it's then not a repeating decimal, but 3/4. There we go. All right, I do know math. Okay, so 3/4 amps, right? So I can show that on here. In fact, maybe we'll do the coal car analogy, okay? So what we're saying is the coal cars come out of the coal mine, out of the battery, all charged up with coal, right? 12 joules worth. And the multiplier here is 3/4, okay? 3/4 of an amp. All right. So, and we remember that means that that's also the current throughout the circuit, right? So that's I1 and I2 and I3. We're not going to bother writing that. So we assume that you know that the current is the same throughout. The other thing that's left to be found here is how much coal is used at each power plant, right? How much the voltage drops across each resistor. And the way that you can do that is just use Ohm's law for each resistor. Okay, let's go to this first resistor here. Okay, that would be, so this right here, right, the voltage drop, how much coal is used here is V1. So the way I do that is, again, I say V1 equals I1 R1. Okay, and the current that goes through there is 3/4 of an amp, right, or 0.75 amps. We already found that. And the resistance of that part of the circuit is 2 ohms, right? So we get a voltage drop here of that is 6/4 or 1.5 volts. Okay, so that's how much the voltage drops here. That's how much voltage is used. So if we now draw the coal car, right, for this part, okay, it's still times 3/4, but you lost 1.5, right? So 12 minus 1.5 is now 10.5 joules. So now you only have 10.5 joules, okay, of the 12 that you started with. And now you work your way through the circuit and you do a similar thing for each of the other two. All right, so I get to resistor 2, V2 equals I2 R2, and we see that that is 3/4 amps times 6 ohms, and that works out to 18/4, which is 4.5 volts. And I'm going to go ahead and do the voltage across the third resistor as well. Okay, and then we'll have all those numbers. And then we can finish with the coal mine analogy. So this is 24 divided by, this is actually 6 volts. Okay, so those are your voltage drops across each of these 3 resistors, okay, to how much coal is used, so to speak, right? So this is V2 equals 4.5, and this is V3 equals 6. So what we want to do is illustrate that with the coal car analogy, right? So this coal car comes into this power plant with 10.5 joules, then it loses another 4.5, right? So it comes out here, okay, with 10 minus 4.5, that is 6 joules, right? Times, better make a little space here, times 3/4, okay? And then that coal car with 6 joules comes into the last power plant, and as always, right, the coal cars go back into the coal mine empty, right? Or in electrical terms, the charges enter the negative end of the battery with no energy left. They are de-energized, okay? Now, let's zoom out. Let's count how many times we used Ohm's law. Okay, we used it 4 different times, right? Once for the overall and once for the three resistors. So now you might get an idea of why we're saying let's Ohm's law this circuit to death. Okay, but Ohm's law works on the overall circuit and it works for each part. There you go, series circuit.